Hello, in this lecture we will study about the properties of nucleus, about the nucleons, binding energies, nuclear fission, nuclear fusion, etc. We start with the composition of nucleus. As you know, all nucleus are made up of protons and neutrons, except the hydrogen atom, which has only a proton in its nucleus. But the isotopes of the hydrogen, like deuterium, tritium, they have the neutrons also in them. So the protons and the neutrons are present within the nucleus and it collectively called nucleons. Proton is a fundamental particle and its positive charge, which is equal to the charge of electron, that is 1.6 into 10 to the power minus 19 coulomb. And mass of the proton is 1.6 into 10 to the power minus 27 kg. Means protons is roughly 1836 times heavier than the electron. And the neutron is electrically neutral. And its mass is 1.675 into 10 to the power minus 27 kg. It is 1840 times. So we can say that the mass of neutron is approximately equal to the mass of proton. The atomic number, the number of protons within a nucleus, is called its atomic number. Atomic mass number is the number of nucleons present in the nucleus, that is the sum of the protons and the neutrons, is called atomic mass number. That is, mass number is represented by A, Z is the number of protons, N is the number of neutrons. Atomic mass unit, that is 1 AMU, is defined as 1/12 of the mass of one atom of carbon. As you know, that is the 6.023 into 10 to the power 23 atom is equal to 12 gram. It means the mass of one atom of 6C12 is equal to 12 upon 6.023 into 10 to the power 23, and 1 AMU, which is equal to 1/12 of mass of one atom of 6C12. So 1 AMU equals to 1/12 into 12 upon this one, and it is equal to 1.66 into 10 to the power minus 27 kg. The size of the nucleus, it doesn't have a sharp or the well-defined boundaries. However, the radius can be given by the relation R equals to R naught A to the power 1/3, where A is mass number and the mass number is sum of neutron plus the protons. And the value of the R naught is 1.2 into 10 to the power minus 15 meter, or you can say 1.2 Fermi meter. So the size of the nucleus is vary from 1 Fermi to 10 Fermi depending on the number of nucleons. And the size of the hydrogen nucleus is very small, while the size of the uranium nucleus is very large. Now, how can we find out the volume of the nucleus? As you know, the formula for the volume is 4/3 pi r cube. So the nuclear volume is given as 4/3 pi r naught cube into A. Now the nuclear density. Nuclear density, as you know, density is mass upon volume. Same is here, the nuclear density is the nuclear mass upon nuclear volume. So first we find out the mass of the nucleus. If A is its mass number, then the mass of the nucleus is AMU, and 1 AMU is 1.66 into 10 to the power minus 27 kg. And formula for the nuclear volume 4 by 3 pi r cube, putting the values. Now density is equal to mass upon volume, so we divide the density is mass upon volume, so we divide this two and we get this relation. Now see, density of the nucleus is very high. You know that the density of the water is 10 to the power 3 kg per meter cube. When we compare the density of the nucleus with density of the water, it is clear that the nuclear density is 10 to the power 14 times higher than the water. It means the nucleus is very dense or heavy. Moreover, it does not depend on the mass number. It means the nuclear density is same for all type of nuclei. Whether it is a hydrogen nuclei or the uranium nuclei, the nuclear density is same. Thank you and have a nice day.